Scaling Kubernetes applications can be a real headache. Trust me, you start with the best intentions, relying on CPU and request-based scaling like everyone else. But here's the thing, it's often not enough. Picture this, your app is doing great, but then there are sudden surges in demand overwhelming your servers. Kubernetes just can't keep up with this, causing crashes and really angry users. Really angry users. This happens because autoscaling in Kubernetes is slow, especially if you have add-ons like Istio configured, or if you're using something like Java, or worse, you need to spin up new nodes to scale your pods. Actually, the main problem is Java. Don't use Java. On a serious note, it was a terrible user experience. I had to fix it. So how did I do it? I scaled my application based on the anticipated load before it actually hit. Hey guys, it's me, YourTechBud, and in this video, we're gonna implement predictive autoscaling using Keda in Facebook Profit. So here's how I did it. It's a 4-step approach. First, decide the output and inputs for our machine learning model. Then we select a model and we train it. We'll then integrate the setup with Kubernetes, and finally, I'll share some important notes to run all of this in production. Let's call that tips and tricks. Alright, we start by deciding how the input and output parameters of our model should look like. This is by far the most important step. I could have saved hundreds of hours if I had paid more attention here. Let's begin with the output, or what the inference process should look like. I want to be able to provide this model with a particular timestamp. It should then spit out a replica count corresponding to that timestamp. In other words, we want the model to output the replica count as a function of time and that alone. So we are building a time series forecasting model. It's important to remember that it doesn't matter what features we train our model with. It could be anything. For inference, we only care about time. This is important for some pretty dope optimizations. We'll get back to it later. So what should be our input feature? Using replica seems to be the easiest to use, right? I mean, one single query in Prometheus should get us the data we want. And that's exactly what I did. And it was a bad idea. The thing is, as you predict more and more into the future, the performance of the model decreases. It becomes inaccurate. The only way to tackle this is to keep retraining your model. And if you've selected the replica count as your input feature, you're technically using the forecasted output as the input for subsequent training. This means your input itself is biased now. Nothing good can come out of it. One way you can solve this is by multiplying the replica count with something like the average CPU utilization. This way, even if your model had over-provisioned the application, meaning if your replica count was higher than it should have been, the CPU utilization would drop and regulate the product value. Same holds true for the other way around. This way you can kind of self-correct the bias which would otherwise seep into your model. I think this is what they call feature engineering. That's such a fancy word. Another way is to use a feature which is kind of decoupled from the replica count. Something like the request throughput. That's exactly what I'm going to show you in this video. But in this case, you need to apply some pre-processing to transform the request throughput to a corresponding replica count. Don't worry, we'll get to that. Now that we have all that figured out, let's move on to creating our model. I'm going to be using the Facebook Profit algorithm. Why? Because ChatGPT told me so. And I cannot go against my lord. To be honest, after trying several algorithms including Sarima, I genuinely think Profit is probably the best algorithm to use here. It requires no human intervention, handles seasonality really well, and the training process is extremely quick. So here's how you train your model. You first load your input dataset, which is the request throughput observed with respect to time. It looks something like this. Okay, so this may have been generated manually. I'm sorry, I misplaced the original dataset I was playing around with earlier and I just can't find something online. To compensate, I have shared a notebook to generate this dataset by superimposing some sinusoids with white noise. It isn't the best, but trust me, Profit should work just fine with your data as well. After loading the dataset, we configure some parameters we know about the input. Things like the time resolution and the length of the dataset. We then transform the request throughput to the number of replicas by applying a fixed conversion ratio, which is 50 in my case. Now I know what you're thinking, Josh. How did I arrive at this number? What's the math behind it? Well, you derive this number by performing an exercise known as application profiling. Here, you progressively increase load to your application and observe its performance. You find this magic number by picking the point where the observed performance starts to drop off. For now, we'll stick with 50. And don't worry, I will be making a video on application profiling and how you can integrate that with everything we are doing today. So it's probably a good time to subscribe. So this is what our data set looks like. Not that realistic, but it will get the job done. Let's split the data into training and test data sets. And finally, let's train our model by writing just 2 lines of code. Alright, the model is trained. Let's make a prediction and plot the output. The orange line is the original dataset and the blue is the forecasted value. It looks pretty accurate to me. Let's just calculate the root mean square error to be absolutely sure. It seems like our model is off by 1 replica. That's kinda expected. So overall, our model is pretty accurate. Finally, we'll store the prediction in a CSV file for safekeeping. Now let's talk about inference or how we can use this freshly trained model. As we've already discussed, we want to provide the model with a timestamp and expect a replica count corresponding to that timestamp in return. Normally, I would write some Python code to power this use case. But hey, I don't like Python. So let's investigate a better way, shall we? We already have our prediction data in a CSV file which looks kind of like a table. And you know a great place to store tables? A database. And that's exactly what I did. I dumped the entire CSV in Postgres. I then wrote a simple SQL query to retrieve the replica count against the current timestamp. If your resolution is really tight, or if you want to give more time for your applications to scale, you can modify the query to look a little bit more ahead into the future. And just like that, we have deployed our model. Feel free to use any database you like. I just chose Postgres because it's already part of my stack. The last step of the puzzle is integrating the model with Kubernetes. That's where Keda comes in. Keda is a superset of the humble HPA which we all love and sometimes hate. It allows us to scale based on a variety of input metrics, including scaling based on the result of a SQL query. I won't get into the depths of Keda today, but if you want to learn more, I've made a video on Keda you should absolutely check out. For now, we will simply write a Keda scale object and provide a SQL query as a parameter to the Postgres scaler. That's pretty much it. Alright, so I've got my application running on top. There is no HPA or anything attached to it right now. I made a Keda scale object here with the SQL query, and the database is already populated with the prediction data. So let's apply it. Oh, and yeah, the only scaler that's going to be used here is going to be powered by our model. So if the replicas start to increase, okay, oh, wow, oh my god, it's actually creating pods. It's working. Yes, it's my first machine learning project, okay? I got a little carried away. Now before you go on deploying this model straight to production, there's a few tips you need to know about. First, make sure you keep retraining your model and update the prediction data in your database. You can run this as an automated daily job or something. This job will pull data from your observability stack, train Prophet, predict a couple of days ahead, and if the error rate isn't too high, deploy the model to Postgres. Deploy to Postgres. That just sounds weird. The second important point is that you would require human intervention from time to time. Set up a framework to continuously monitor the model's performance. The error rates do tend to shoot up as your workload pattern changes, so keep an eye out for that. The third point is about using multiple input features. You can do this by training models for each feature separately and deploying them as separate Postgres tables or columns. Keda supports having multiple triggers, so you can have one trigger for each one of them. Try to avoid using multivariable model as much as possible, unless you start noticing errors due to over-provisioning. The last advice I have for you is to always have a backup scaler. Your model isn't gonna be perfect. And trust me, I have kind of made that mistake before. A backup scaler like scaling on CPU helps protect you from under-provisioning. Always have that configured. Now as a next step, you should absolutely check out this video because YouTube has predicted it to be the best one for you. Strongly recommended. Like, share and subscribe if you found this video to be helpful, And don't forget, I am your TechBud here on YouTube and hopefully in real life.